again. Let's see if I can work through these problems. So exponential growth and decay are our two formulas that we talked about the other day. And hopefully y'all can see this okay. I don't know whether to make it brighter. Let me see what I can do real quick. Can't really make it brighter. Okay, well, we'll just roll with it and see what happens. Okay, so exponential growth and decay. Okay, so our formula, first one we're going to talk about is growth. We did treat these separately in our notes, okay? But the formula is going to be very similar, all right? So we're going to start with whatever equals, and then we're going to put our a outside, which is our initial, and then 1 plus r to the t. So again, our a is our initial amount. Our r is our rate, and remember that has to be as a decimal. Okay, and then our t is our time. And the one thing about time is you do want to make sure that they match whenever you're doing these. And I don't think any of the ones we have today are like that, but we'll talk about that once we run across it in our notes. But real quick about rate, okay? So for instance, if it is a 25% rate, okay, we're going to write that as 0.25. If it is a 4% rate, we're going to write that as 0.04. If it is a 1.2% rate, we're going to write that as 0.012. So you will always move 2 places to the left. Okay, so that's where that 0 came in, and that's where that 0 came in. Okay, so it's always 2 places to the left whenever we write our rate out. Okay, so given that, we're going to jump right in. Okay, so the original value of an investment is $1,400, and the value increases by 9%. All right, so 1,400 is going to be our A. Okay, it increases by 9%. So increases is telling me growth. So that's going to be our R, which is 9%. And we're going to write that as 0.09. And they want to know how much, what the value of the investment is after 25 years. So our T is 25. So I'm going to plug it in exactly like you would see it in the formula initially. Okay, so it's going to be Y equals 1,400, 1 plus 0.09 to the 25th. Okay, now on your EOC, a lot of times they are going to go ahead and combine this together. It doesn't matter mathematically, and I will show you that here. Okay, so if I was just to type in 1400, the first one, 1400, 1 plus 0.09 raised to the 25th, okay, it gives me that. If I combined it and just made it 1.09 and raise that to the 25th, I'm going to get the same exact answer, okay? And we are talking about money here, so we're going to round to 2 decimal places. And 12,072 and 31 cents would be our answer. Okay. All right. With this newer Elmo, I am having to write with different pens, so just be careful for now. I'll get it figured out, y'all. I promise. Okay. All right. Cost of tuition to college is $1,200, so our A is the $12,000. And our rate is 6%. So 6% is going to be 0.06, and our time is going to be after 4 years. Okay. So again, Y is going to equal 12,000. 1 plus 0.06 to the fourth. Okay, and we're just going to type that straight in. 12,000, 1.06, and raise that to the fourth power, and we're going to get 15149.7. Okay. All right, and I'm not going to continue to show my calculator every single time just because it does take a little bit of time to try to get that up there. So you're literally just typing these in, raising that to the correct exponential from there, okay? All right, so here we go. 300 students, so that's our A. It's increasing at 8% per year, so that's our R, which we're going to put 0.08. And then our time is after 5 years, okay? So Y is going to equal 300, 1 plus 0.08 to the fifth, All right, so we did talk about this in class. In math, a lot of times we do round. Uh, in general, okay, money we always round to two decimal places. Because that's what money is. A lot of times it'll say in the problem to round a certain thing. Okay, so I will show you this one. So this one right here is 440.798. Okay, we're talking about people. Remember we talked about anything that is living, animals, people, bacteria, things of that nature. Okay. We're going to round to the nearest whole number. If you rounded this to the nearest whole number, okay, it would be 441. But technically speaking, you're talking about people here, so we don't count any part of that decimal, so it would be 440. However, if you put 441, I would take either of those answers, and we talked about that in class. So if you have any questions about that, just see me and I'll explain it further, okay? All right, so number 4, same thing, y'all. It's just a process. Okay, so we're just going to start filling it in. So 149,999 is increasing, so that's going to be 1 plus 0.06 to the 7th. And again, I will always make sure you're familiar with combining those together. Okay, so this time again, we're talking about money. Okay, so we're going to plug that straight in. And I got $225,543.04. Okay. All right. Let's keep rolling on growth. Population of a small town is 1,600, so that's our A. Okay, 3%, so that's going to be 0.03, and our time is 10 years, and plug it in. So 1,600, 1 plus 0.03 to the 10th. And again, we're dealing with people, so we're going to knock off that decimal part. Oops. Okay, so I'm going to end up with 2,150. If it could be either or, I will let you know that. Okay. All right. And the last one down here. Okay, so we started with 285. It's going to be increased by 75%. So that's 1 plus 0.75. And we want to know in 2008. Okay, so this time it didn't tell us the years, but it started in 1985 and we're going to 2008. So we're simply going to do 2008 minus 1985. Okay, and that does give us 23 years. So we're going to raise that to the 23rd power. So again, that's 285, 1.75 to the 23rd power. And that gives me a lot, y'all, a lot. And again, we're dealing with people, so I'm going to drop off that decimal. So it's going to be 110,845,988. All right. And then we switched gears and went to decay. Like I said, we switched it, treated them as two different topics here. Okay. Literally, though, it is going to be the same formula. Okay. The only difference is for decay, our formula, instead of containing a plus, it's going to contain a minus. Okay. It's still the initial amount. This is still our rate as a decimal. And this is still our time. Okay. So again, just look at your context, look at your vocab to kind of decide which one you're going to use. There will be keywords in there definitely to tell you. Okay. All right. So here we go. Population of a town is decreasing at a rate of 1% per year. In 2000, there were 1,300 people, so I'm going to start with 1,300. It is decreasing at 1% per year. So 1 minus 0.01. And again, from 2000 to 2008 is going to give me 8 years. Now, this is where it's a little different. We are decreasing. Remember, percentage is always out of 100. So when we subtract that, we're going to have 0.99. Y'all think about it in terms of like shopping. Like if there's a sale for 20% off, you're actually paying 80%. And the way you get that is you take 100 minus the 20%. So we're doing the same thing. We're taking 100 minus the 1%, and we're getting a 99% uh, rate there, okay? So we're going to do 1,300 times 0.99, or again, you can plug in the top one. It doesn't matter. Get the same answer. And we are dealing with people, so it does come out to be 1199, 1199, or it does round. That's a 0.5. So if you had 1,200, I would take either of those, okay? All right, number 8, we've got 18,000 as our initial. We are depreciating, that's our decay, at 12%, so 1 minus 0.12. Okay, after 10 years, so to the 10th. So 18,000.88 to the 10th is what I'm going to plug in. And that's going to give me 5. We're talking about money again, so that's going to give me 513.02 when I round. Okay. All right. Farmer buys a tractor for 50 grand, so 50,000 is our initial. It depreciates at 10%, so 1 minus 10, and 7 years. So again, if I subtract, that's going to be 90% that it's actually being valued at. And that's going to give me 23,914.85. 2 decimal places, again, talking about money. All right. Again, pause the video at some point. Do some on your own if you weren't here whenever we did these. So you can make sure that you're not just copying what I'm doing, that you're actually comprehending what is going on. Okay. But I don't ever do these until after the fact. So it's really usually for people to go back and review more so than be taught. But if you weren't here, so on your own. All right. So we're losing 2%. So that's give me a 98% there. 9 years, and we go with value of book is $58. It is decreasing at a rate of 7%, so 1 minus 0.07 after 8 years. So 58, 1 minus 0.07 is going to be 0.93. Again, 100% minus 7% is 93%. What you're doing there. And be careful. I just typed that in and forgot to raise it to the 8, so it looked like I multiplied it times 8. And when I did that, just to show you real quick, when I did that, I got 431, which doesn't make sense. It is not less than 58, okay? So be mindful of that as well. Okay, so we're going to say 32, 40. All right, and number 12, the population of a town is decreasing at a rate of 2.5% per year. Okay, so if the population of 2000 was, so our initial here is 28,000, decrease, that's going to be 1 minus 0.025, and we're going from the year 2000 to 2015, which is an exponent of 15. So 28,000, 1 minus 0.025 is going to give me 0.975 to the 15th. Okay. And again, we're talking about population, so I'm just going to knock it off. It's going to be 19,152 or 19,153 because it could have rounded up. Okay, so that was everything that we did in terms of just growth and decay. simply plugging it in straight into the formula. However, that day we did also do something called rate of exponentials. Okay, and that is where we had to take what we knew here, and y'all, these are so small. Give me a minute. I had to figure out. I don't want to zoom too far where it's blurry, but I need y'all to be able to see it. Okay, so we'll go right there. All right. So in doing this, what we're going to see is that we are dealing with trying to calculate it back to the original almost. And sorry, I'm trying to grab some more pens, y'all. Like I said, it's hard on this new Elmo, these lights. Okay. All right. So what you have here is they've already given it to you in simplified form, and they're asking you what is the rate of growth or decay. That's what they're asking. Okay. So we're going to look right in here. Okay, at 1.35, and whatever that is, we're going to subtract 1, which is going to give me 35%. I need to hold on. It might not let me focus much more than that because it's so zoomed in. All right, we'll go with it. Okay. All right. And then again, we're going to move that 2 places over. So this is 35%. If this is a positive number, or if this number is greater than 1, it's going to be growth. Okay. This was in the same day. That's why I'm doing it now. Okay, so moving over here. Now, if you notice this number right here, 0.44, it is less than 1. So automatically, I know we're going to have decay. So all I'm going to do is I'm going to do the same exact thing. I'm going to say 0.44 minus 1, and that's going to give me a negative 0.56. Y'all, the negative sign just tells me that it is decay. It is not part of my answer. Okay, I'm going to move it 2 places over, and it's going to be 56% decay. So if it's negative, it's decay. If it's positive, it's growth. That's what you're dealing with. And then they're asking you what is the percent. Okay, so same thing right here. 1.14 is greater than 1. So we're going to subtract the 1, which leaves me with 0.14. Move it, and it is 14%. Greater than 1 is growth. Okay, and then 0.68. So immediately less than 1, you can tell me that it is decay. So when I subtract that, that's going to be negative 0.32. I'm going to move it 2 places, so that is 32% decay. Okay. So that's just them asking you specifically, hey, given this, what is the rate that you had before they simplified it? Okay. And these don't take very long at all. Towards the end, there's an extra step on a couple of them that we'll talk about. Okay. So they don't take too long at all. All right. 0.89. So 0.89 minus 1 is going to give me negative 0.11. Move it over, so that's 11% decay. You are always subtracting that 1 because that 1 is part of the formula. Okay, so we're trying to get rid of that 1 out of the formula. All right, so now these next few are the ones that are a little different, and you'll see it's because there's not just an x outside. Okay, so because there's not just an x outside, we can't just subtract 1. We've got to get that as an x outside. Okay, so what I'm going to do is use my exponent rules. Okay, again, I'm ignoring this right now. I'm right here, 0.5 to the x over 4. Okay, I can rewrite that as 0.5 to the 1/4 times x. And remember, knowing our power to a power rule, when it's a power to a power, you multiply. So I can move that 1/4 inside with my 0.5, and now I have my x. So then all I'm going to do on my calculator is type 0.5, and I'm going to raise it to the 1/4 power. Okay, so that's what I have right there, and I'm going to hit enter. And I want these first two, okay, round if you need to, so that's 0.84. So I have 0.84 to the x. Now it looks like what I've been doing. So I'm going to do 0.84 minus 1, which is going to give me negative 0.16. which tells me that it is 16% decay. But you can't just tell me that it's like 50% decay from the get-go, okay? Oh, crazy. Okay, we're gonna do the same thing here. All right, so I'm gonna jump right here. So it's gonna be 1.05 to the 2/3 x. So I'm gonna move that 2/3 inside with my 1.05, and that's what I'm gonna calculate. I'm gonna calculate 1.05 raised to the 2/3 power. So that's gonna give me 1.03. I'm going to subtract my 1, which leaves me 0.03, which is a 3% growth. And again, growth and decay are the same regardless, as far as here it was a 1, therefore it's growth. There it was less than 1, it was decay. That didn't change, okay? This one we're going to go 0.4, and we're going to raise that to that 3/4 power. And that's going to give me 0.50. We're going to subtract 1, and we'll get negative 0.50, which is a 50% decay. See if I can move that. Sorry. There we go. All right. And then I think there might be 1 or 2, oh, 3 more. Just kidding. Okay. So, oh Lord. If y'all knew the frustration that this gives me. Okay. So we're going to go 1.25 to the 2/5. Okay. And that's going to give me 1.09. We're going to subtract our 1, which leaves me 0.09. So that is a 9% growth. Okay. Moving over here, it's going to be 1/2 raised to the, and x over 4 is 1/4. Okay, so y'all, if you want to put in 1/2, you can. 1/2 is the same as 0.5. You can do that. 1/4 is the same as 0.25. It doesn't matter, okay? So that gives me 0.84. So now I'm going to say 0.84 minus 1, which is negative 0.16, which is 16% decay. Okay, and one more. So we're going to go 1/5 raised to the 3/4. And that gave me 0.299, which is going to be 0.30. So I'm going to say 0.30 minus 1 is negative 0.70. So that is 70% decay. And that is it for